Hi everyone, my name is Mohammed Shafiq and I'm the IoT and Cloud Enablement Product Manager here at Siemens Embedded. And today we're going to talk about enabling IoT use cases on embedded devices and also building feature-rich mobile and web applications for the IoT solution using Mendix low-code application development platform. Before we go into details of enabling IoT, let's talk about an emerging trend that is very important for the device builders these days, where they're connecting their devices to the internet, which were previously not connected or standalone devices. And this connectivity enables these device builders to collect and share data from the devices that are working in the field. They can enable digital workflows around these devices. They can get real-time alerts and alarms from these devices. And as the compute and storage resources are improving on these devices can react autonomously in the field and then can behave in an intelligent and smart way. These devices have more and more capabilities to process large amount of data and then send back the results to a cloud backend. And then this connectivity also enables device builders to remotely manage and provide maintenance services on these devices. So mainly device builders are looking at three advantages when they build in the connectivity. So they want to provide enhanced user experiences where instead of providing the old panel-based user interfaces, they can now involve mobile applications or web applications to interact with these devices. They can improve their service and maintenance for these devices because now they can remotely do configurations, provide firmware updates on these devices. And then this connectivity also enables device builders to offer new services around those devices. Let's take a look at some of the use cases that device builders want to enable as they connect their devices to the internet. Starting with the operator use case, where device builders want to offer rich user interfaces around their devices. So instead of having an old panel, the user can use a mobile app on their smartphone or handheld device to interact with the device. They can remotely control the device or set up some notifications. So this can provide much more rich interaction capabilities around the device. And then because of this connectivity, the device builders now have the ability to provide better service plans where they can do full fleet management, firmware updates, remote configuration calibrations. And then this capability also allows them to offer some value-added services. So they can have a app ecosystem around their devices. And then as this connectivity provides them the opportunity to get more and more data around their devices, they can improve the devices as they come up with the next generation of the device. And this also provides ability to offer some new business models and new services around the devices. And then on number 6, we have the general benefits of this approach, where the developers also have the ability to incrementally update the functionality on their device. They can start with a smaller or a less feature-rich version of the app, but then over time they can add more functionality. So when we look at the IoT enablement on devices, we should look this through as a kind of a maturity curve or an IoT journey. So it's typically starts at a very basic use cases where we will implement telemetry or ability to remotely gather some information and explore data around the device. But then as they get more and more capable, they can discover rich insights from that data, and then start reacting or implement some controls on the device that react to the data analysis, and then eventually they go on and transform their businesses. So this is we should not think of this journey as a kind of a simple or one time offering, but it's an evolution where you start small, but then you can really transform your business. So let's take a look at what needs to happen on the embedded device side when you embark on this IoT journey. Obviously, the first thing that you would need to do on your embedded device is to enable the connectivity via cloud, or if you're implementing an on-prem system, you'll need some sort of connectivity servers. Apart from that connectivity, this is kind of your basic enablement or your base to start your IoT journey. But then you need to implement services like firmware updates, configuration and control mechanisms, ability to gather some data from the device, diagnostics, be able to debug your device remotely. So all those different services are need implementing, and implemented in a way that you have a secure control around your device. Then the device builders have the option that they can invest and investigate all these new services and implement incrementally on their devices. Obviously, this will have cost to their in-house development, and then this will take time. And the other option for the device builder is to take this component or this piece of the middleware from a commercial vendor to quickly enable these services on their devices. So this is where the Siemens Embedded can help, where Siemens Embedded has a long history of providing quality embedded software for the embedded devices. So the Siemens Embedded provides the real-time operating system, Nucleus, few flavors of Linux for different needs. There is a multi-core framework, hypervisor, a different type of tooling, and Siemens Embedded has experience working with a variety of different SoC environments, multi-core, homogeneous, heterogeneous, very feature-rich processors or low-end microcontrollers. And then in addition to this portfolio, we have now the IoT framework that can help you enable the IoT use cases. So everything that we talked about in the previous slide, from cloud connectivity to different services on the devices, they're all bundled into this IoT framework. So this enables this whole embedded software portfolio, IoT enabled very quickly and in a supported and efficient manner. So this slide summarizes the IoT framework. So this, at a very high level, this provides the cloud connectivity. So you can see different cloud vendors that are already enabled on this IoT framework. So the end user can pick the cloud of their choice. And then in addition to the cloud connectivity, the IoT framework provides different services from device management to security, enablement, diagnostics, profiling, application management, firmware update capabilities. And this framework is available on different operating system environments. So whether you're using a Yocto-based Linux environment or Debian-based Linux environment or a Nucleus real-time operating system, this framework is enabled and can help you enable IoT on your devices fairly quickly. So let's take an example of one of the services that how IoT framework helps you quickly bring rich use cases to the devices. So the firmware update or system software update is one of the key promise of the IoT. And this is one of the complex feature to implement. And this is pretty involved process. So so the cloud connectivity is one piece that enables the remote interaction. But before you do those remote interactions, you need infrastructure to enable your devices and your build environment to be able to generate firmware update artifacts. You generate the artifacts, you sign them, you encrypt them, you send them to a cloud repositories so that devices can access them. Then you need to have this ability to initiate the firmware updates on the devices, and devices be able to pull those artifacts. And on the device side, you need infrastructure to decrypt and validate that payload, the firmware update payload. And then once it's validated, the device needs to apply that firmware update and then reboot and see if everything works fine. If there are issues, then the device should have mechanism to roll back to the last known good condition. So this end-to-end implementation is pretty involved. So the IoT framework enables you to get all different parts and pieces of this use cases implemented very quickly. So let's then talk about the other aspect of the IoT enablement. So the IoT framework focuses on the device enablement or the IoT on the device. But then the web or mobile application is another key component for the IoT solution, where the user will have to remotely interact with the devices. So this slide describes what are the different reasons or scenarios where the web or mobile app might be useful. So in the first scenario, we have an operator of the device. So he may want to connect to the device locally, let's say over a Bluetooth connection, to do configuration or to operate that device. So you can set up alarms, or you can set up some do scheduling around the devices using the mobile application. And then on the device builder side, you can have a service technician mobile app that where he can remotely monitor equipment or a device and run some diagnostics. Or you can go to a close proximity of the device and run calibration or do some diagnostics. So the mobile applications or web applications provide a rich mechanism to interact with the devices locally or via cloud connection. So here, the Mendix, the low-code application development platform, comes in. So Mendix is a full-stack platform to develop mobile and web applications. And the approach that it takes is that that even if you don't know how to code mobile or a web application, it provides the whole framework where you can visually start implementing your application instead of going into the deep technical setups and the back-end environments. So the team can very quickly focus on the application aspects instead of bogged down into the environment and infrastructure maintenance. So the Mendix platform has three different models. So where you can do a purely no-code application development. This is geared towards more high-level developers who don't have any experience at all in the coding. Then you can also do kind of mixed mode coding, and then you can also bring in, if you have some existing code or experienced developers who already have expertise in different technology areas, then they can write custom code as well. So it's a pretty flexible environment and enables the whole organization to start developing the mobile or web applications for different use cases. And this framework enables you responsive apps for different environments, whether you're doing a mobile application or for a tablet or a desktop environment. This environment can very easily support different views and fully responsive applications. This slide represents how we offer, from a Siemens Embedded perspective, a kind of end-to-end environment to build both sides of the story using Mendix and the IoT framework. So the IoT framework that's focused on the device side and enables the cloud connectivity. So we provide reference application where the cloud, from a cloud, you can connect to an Mendix application, and then depending on what cloud you are using Azure, AWS, or MindSphere, you can interact from a Mendix application to the embedded device. And this allows you to implement the use case where a user wants to remotely monitor and remotely issue commands on the embedded device. The other model where the Mendix integration is available is a local Bluetooth-based connection. So where a user can be at the close proximity of the device and connect using a Bluetooth connection. And this allows a kind of a non-cloud connection and you can leverage the proximity to the device. And this can also help in the scenarios where the remote connection to the device is not possible because of the firewalls or security reasons. So as part of the offering, the Siemens Embedded IoT Framework provides some reference applications. So this is some mock-ups of the native applications that can connect using a Bluetooth connection to an embedded device. So you connect and then you can do some configurations using your mobile application. You can issue the commands using that mobile application on the embedded device, and then you can also monitor different variables, what's going on the device, whether that's telemetry variables or some device diagnostics. So that all is available through a mobile application. The other scenario that I mentioned, connecting to a mobile application through a cloud, that's also provided as a reference application. We're actually going to see an actual video of that end-to-end system working. So here you can see kind of at a very high level a story that where an embedded device like a fan unit is connected to a Mendix application using a cloud connection. So let's play the video and see how the embedded solution comes together with the Mendix to offer an end-to-end experience. So typically these fan units have these wall units where you can observe the ambient conditions around the fan unit. But now if you connect this to a cloud and then a Mendix application, then the Mendix application provides you the ability to remotely monitor different functions around the fan unit. For example, you can do different configurations, you can set up alarms, you can receive events, you can do the reboots or configuration changes. So this particular command shows how you issue a ping command to see if this device has a valid connectivity. And then we showcase the fleet management or the full firmware update using the Mendix application on a fleet of fan units. So here you see a fleet of fan units, and let's say you want to do a firmware update to a subset of these fan units. So you create a group of these fan units. and give them a label. Now, for this group, let's say we want to create a deployment and send a new firmware update. So here in your firmware update configuration, you can choose different firmwares that might be available for your fan units. And then you basically schedule your deployment, whether you want to roll out immediately or you want to schedule for a later time. For the demo purposes, we just send a firmware update immediately. And then you can also define different phases for your firmware update to happen. For example, if you have a large number of devices, you may want to incrementally update your devices. So you can define different phases, and then you can basically initiate the firmware update. And then the Mendix application allows you to very closely monitor what's going on in the field. So it can provide you fairly fine-grained insight into the firmware update process. So you can. So this is a kind of summary screen where you look at different aspects at a high level, but then you can also look at the details and look at exact devices, like what's going on each device, which one are passing, which one are failing, and how's the overall progress. So here on the inset, we see the UI on the local control unit for the fan. And as part of this firmware update, we're actually sending a new UI for that wall unit. So as the firmware update completes and the device reboots, you'll see a new UI popped up on the wall unit. So this showcases a successful firmware update using a Mendix application on an embedded device. And then once this update is complete, the device goes back to its regular function, and you can keep monitoring the ambient conditions remotely using the Mendix application. So this Mendix application was using a MindSphere as the intermediary between the Mendix application and the device. So everything, all the interactions are going through the Siemens MindSphere platform. So that brings us to the closure of our session. So I'm very interested to know what next IoT project you are building, and you can try Siemens Embedded and Mendix to see if this can enable you to quickly bring something to the market and evolve your solution from there onwards. Thank you for joining.